So this is another one of these airplane questions involving airspeed and ground speed and wind speed here. So we're told that a navigator wishes an aircraft to fly on a bearing of west 22 degrees north with a ground speed of 300 kilometers per hour. So that is obviously the ground speed or the ground velocity that we're given here. So we want to go west 22 degrees north, so that's north, that's west. So our vector has to go something like this. It's got a magnitude of 300, and it is 22 west, 22 degrees north, so that's 22 degrees north of due west. And we'll just say that this is our ground speed. We're also told that there's a 60 kilometer per hour wind from the direction south, 15 degrees west. So this is obviously our wind speed. So if we go to south, 15 degrees west, we're looking at something like this, where this angle in here is 15 degrees, and this thing has a magnitude of 60 kilometers per hour. Now, the wind is from that direction, so this vector points in towards the origin. So those are the two vectors we're given, and what we're trying to find is the airspeed and the heading. So we want to find this air velocity vector, A. And we're going to use this relationship that the ground speed is, or the ground velocity is the air velocity plus the wind velocity. But if what we're trying to find is the air velocity here, we want to rearrange this. We'll bring the wind velocity over to the other side to get that the air velocity is the ground velocity minus the wind velocity. And the other way of thinking of this is that instead of subtracting the wind velocity, we're going to think of adding the negative of the wind velocity vector. So if we can add the ground velocity and the negative of the wind velocity, that should give us our air velocity. So let's take a look at our wind velocity down here. It's pointing at an angle of, so we're at 15 degrees west of south. So the negative of that velocity is going to look exactly the same, except it's going to point in the opposite direction. So I'll just draw it like that over top. And when we do the vector sum here, ground speed plus wind speed, we're just going to place these two vectors tip to tail. So we're going to have this can be our ground velocity here, and we're going to add in 60 for minus wind velocity. This one over here was 300. Okay, and the vector sum of those two, of course, goes from the tail of the first one to the tip of the second. This is going to be our air velocity here. Now the next thing we need to figure out is we need to figure out some angles in here. So I'm going to use our little coordinate axes again. Okay, we know that, I'll put one over here too, just in case we need it. So let's take a look first at our ground velocity vector here. We know that if this is 22 degrees north of west, this angle in here must be 68 degrees. So we can fill in that in here, 68 degrees, right there. Well, if that's 68 degrees, then by this little Z pattern in here, this has to be 68 degrees in there. Next vector is going to come from, well, we've got a 15 degrees between the tail of our minus wind velocity and the vertical there. So that tells us that this angle right in here is also going to be 15 degrees. So now we have magnitude of one side, 300, magnitude of the other side, 60, and we have the sum of the angle, and we have the angle, the enclosed angle between the two. The sum of that is just 15 degrees plus 68 degrees, or 83 degrees. So once we have the enclosed angle, we can use a cosine law to find the magnitude of that vector A. So let's set this up here. The magnitude of a squared is going to equal 300 squared plus 60 squared minus 2 times 300 times 60 times the cosine, that enclosed angle, 83 degrees. So we can work all that out and find that the magnitude of that air velocity vector is going to be 298.685. So that's our airspeed. Now we're going to use sine law to figure out the heading that they need to set. And a good angle to find is always the one that is closest, that is inside the triangle, close to the tail of the vector we're trying to find. So we'll try to find that one right in there. We'll call that theta. So sine theta over, let's see, the opposite side is 60, is going to equal sine of that enclosed angle, 83 degrees, divided by the magnitude of that vector that we just found. Say 5, we'll bunch this in and solve for angle theta. We get that theta is 11.5 degrees. Now we want to convert this theta into a bearing for our air velocity. So we could probably do this in terms of degrees north from west. So that means we want to calculate this little angle in here, and that's going to be our quadrant bearing. So we want to turn this, and we want to get that quadrant bearing. Okay, that little green angle in there. So how are we going to calculate that? Well, we've got, the whole thing is 98. We've got 68 degrees to there. We've got theta inside there, which we've just calculated. So the quadrant bearing is going to be 90 degrees minus 68 degrees minus that 11.5 that we just calculated. So the quadrant angle, that quadrant bearing angle, is 10.5 degrees. So let's put all of this stuff together in our concluding statement here. So therefore, we can just say that the air velocity is going to be 298.7 kilometers per hour. We'll just round that off. And for our direction, we have got west 10.5 degrees north, because that angle was 10.5 degrees north of due west. And that's what we were asked to find: airspeed and the heading. So we're done.